Okay, let's have a look at solving differential equations. So if we've got a derivative where we know that dy by dx equals, and it's some function of x multiplied by some function of y, so we'll call it fx times gy. Remember we said that we could kind of treat this dy by dx like a fraction, so if I were to kind of multiply up by the dx on that side and take the gy to the other side, then that's simply going to become 1 over gy dy equals fx dx. And then we integrate each side. And this has got a special name. This is called separating the variables. So let's do a quick example on how we might do this. So for my example, I want to find the particular solution. Again, there's going to be a few solutions because when we integrate we're going to have a constant, but I want to find the solution of dy by dx equals minus 3 y minus 2 all over 2x plus 1 x plus 2. And I'll say that given that x equals 1 when y equals 4. Okay, so let's start to look at the solution to this one. So if I were to kind of move the variables across, I could write that as the integral of, if I move the y, minus 2, be 1 over y minus 2 dy equals integral. The other side's going to be minus 3 over 2x plus 1 x plus 2 dx. Okay, I immediately notice that this side I can't integrate, but I can use partial fractions. So let's split this up into my partial fractions and see what I get. So I'm going to get minus 3 over 2x plus 1 x plus 2 comes out as a over 2x plus 1 plus b over x plus 2. I'm doing my multiplying up. I'm going to end up with minus 3 equals a times x plus 2 plus b times 2x plus 1. And if I let x equal minus 2, I'm going to get minus 3 equals, I'll have no a's because that bracket would be 0, minus 3 b's, so b must equal 1. And if I have a look at the other one, I'm going to say let x equal minus a half. I'm going to get minus 3 equals minus a half plus 2 is 1.5, or 3 over 2 a. So I get a equal to minus 2. If I put that back into my equation, I'm going to get the integral of 1 over y minus 2 dy equals the integral of 1 over x plus 2 minus 2 over 2x plus 1 dx. And if I integrate that, I'm going to end up with log of y minus 2 equals log x plus 2 minus, this one is going to be 2 log of 2x plus 1, but then remembering the chain rule, I then have to multiply it by the derivative of that, which is a half, so we can kind of say the 2 will cancel out, if you like. We're going to end up with that. And then we've got a constant. Now I'm not going to put c this time. I'm going to put it as log of k. It's still going to be a constant. If k is a number, log of k is still going to be a constant value. And I'm using this instead of c. So this is in place of c. And it's used in place of c because then we can, when you see the next time, we're going to be able to get rid of all the logs quite nicely. where we wouldn't be able to do that if that was still a c. So, sorry, if we were to have a look at how we could kind of combine those, we're still going to have log of y minus 2 on that side. And this side, I'm plussing when we use our log rules. Plussing means we multiply, and minus means we divide. So I'm going to write that as log of k times x plus 2 all divided by 2x plus 1. Okay, now I've got log of one thing equals log of another. So at that point, I can cancel the logs. So I can say, well, y minus 2 must just equal k times x plus 2 over 2x plus 1. And I then need to work out k, but if you think right back to the start, we were told that x equals 1 and y equals 4. So if we put those into the equation, we're going to get 4 minus 2 equals k times 1 plus 2 divided by 2 plus 1. So I'm going to get the 2 equals k. So my actual equation for this is going to be y minus 2 equals 2 times x plus 2 all over 2x plus 1. And if I want to simplify this down a bit, I could say, well, that's just going to be the same as y equals 2 plus 2x plus 4 over 2x plus 1. But this fraction here is kind of one of those fractions where the top and bottom are of the same power. So if I do 2x plus 4 divided by 2x plus 1, so that goes in once, 2x plus 1 goes in once, take them away, I get a remainder of 3. Like I say, that's the same as y equals 2 plus, and in place of that fraction, I'm going to put 1 plus 3 over 2x plus 1, or y equals 3 plus 3 over 2x plus 1.